Hello, here we are doing whiteboard problem 16.4. I'm just going to write that down, 16.4. Okay, so we have a fire engine whose predominant frequency is 550 hertz. So that's the emitted frequency is 1550 hertz. I don't know what I just said. Ignore me if it was something different. What frequency do you detect if you move with a speed of 30 meters per second toward the engine and 30 meters per second away? So this means the observer is moving with a speed of 30 meters per second. And then toward and away. And we want to find the observed frequency. Okay, so what does that sound like to you? All right, so we jump over to our camera. All right, and so we're going to need our equation for the Doppler shift. Right, there's a Doppler shift question. So, okay, and so we can have a picture here too. All right, so we get our full credits here, right? So this guy is just emitting sound here, right, at some emitted frequency. That's my fire truck. Something looks wrong there, right? It should be bigger up there. Maybe a light on the top. Okay, and now this is the velocity of the source is 0. But we're going to do one case, right, where you are here, or we'll put you up here. So you are moving toward the truck, and then we're going to see also what it looks like when you're moving that way. Okay, so toward and away. So we know as we're moving toward, we're hitting these crests faster. Boop, 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 boop. So the frequency should be higher. So F observed should be greater than F emitted. And then if you're moving this way, you're kind of outrunning the waves a little bit. And so you see it, you'll hit them slower, boom, 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 boom. So F observed should be less than F emitted for this guy. Okay, so it's always good to just think about this in terms of what you should get, right? And then we work the equation to get us the right sense of the answer. So the Doppler shift equation says that the frequency observed is the frequency emitted, and then we have this combination, right? So we have the speed of sound, and on the top we can have the observer moving toward or away, and then on the bottom we can also account for the source moving toward and away. And we'll, again, just pick the plus and minus based on how we know the frequency should shift. So in this case, the source is not moving, that is 0. So our relationship then is just the speed of sound plus or minus the speed of the observer times the emitted frequency. Okay, so let's think about moving away. So when we're moving away, the observed frequency should be less than the emitted frequency. Okay, and if we want this to be less than this fraction has to be less than 1. So we need the minus sign. We want our numerator to be less. So we have F emitted is V minus the velocity of the observer divided by the speed of sound. It's F observed. Okay, so we can plug in and we get our emitted frequency, 1550 hertz. And we have the speed of sound, 340 meters per second, minus the speed of the observer, 30 meters per second, divided by the speed of sound, 340 meters per second. Okay, so we get the observed frequency is 13 hertz. Okay, and then we're moving toward the source. We want our observed frequency to be greater than the emitted. So again, if we want this side to be bigger than this value, this fraction has to be greater than 1. So we're going to want the plus in the numerator. So F emitted is V plus the velocity of the observer divided by the speed of sound is our observed frequency. And so again, if we plug in all the same thing, we get the observed frequency is 1686 hertz. And just to look at the shift, right, our shift in frequency, we shifted 136.7 hertz on this side, and the shift on when we're going away is also 136.7 hertz. You can say it's negative. Okay, I'll call that done.